What's up, boys and girls? Welcome back to another exciting math lesson. Today we are getting knee-deep into variation by studying what we call the mean absolute deviation. Before we get started, I just want to discuss the overall idea of variability. And if you look right at the start of the word variability, we have the word vary. So if something varies, it means it can differ in some way. So measuring variability means the extent at which data points differ from each other. When we're measuring variability in a data set, we're trying to determine how similar data points are or how different they are. It can measure how widely spread or closely clustered the data values are. So if you have a lot of variability, the data points in your set are going to be very spread out. But if you have a small amount of variability, they'll be more similar. They'll be what we call more closely clustered together. And the measure of variability we are going to specifically look at today is mean absolute deviation. And if you look at the definition, it is the average distance between each data value and the mean. So grab a notebook, grab a sheet of paper. You'll definitely want a calculator for this lesson. Let's learn to calculate mean absolute deviation together. Calculating mean absolute deviation is a three-step process. Step one, we're going to find the mean of the data. So if you remember from a couple of lessons ago, to calculate the mean or the average of our data set, we're going to add all the values together and divide by how many elements there are. Once you've calculated your mean, you're ready for step two. And we are going to find the distance between each data value and the mean. So essentially, we are subtracting every data point in our set from the mean. Once we have all of those differences, and those differences we call, you may want to make note of this, those differences are called deviations. Once we have all our deviations, we're going to find the mean of those distances. We're going to take all of those deviations, add them together, and divide by how many of them there were. And that value will give us the mean absolute deviation, the average distance of each data point from the mean. Here's our first example. We're given the set 112, 145, 108, 160, and 122. And calculating mean absolute deviation is easier with a table. So I'm going to start with a table. And in my first column, I'm going to list all of the values of my data set. So I have 112, 145, 108, 160, and 122. And now we're going to calculate the mean of those numbers. So grab your calculator. And we're going to first sum the values. So we have 112 plus 145 plus 108 plus 160 plus 122. And we get a sum of 647. And we need to divide that by how many elements were in the set. In our data set, we had 1, 2, 3, 4, 5 values. So I'm going to go back to my problem, and I'm going to divide that sum by 5. And I get a mean of 129.4. So the mean, 129.4. Now it's time for our deviations. To do that, we are going to take our data point and we are going to subtract the mean that we calculated. So my first data point was 112, and I'm going to subtract 129.4. Now I get a negative value. My deviation is negative 17.4. Remember, though, we are looking for the absolute deviation. If you remember absolute value, we just want the positive version of 17.4. So the absolute deviation of 112 is 17.4. Next, we're going to find the deviation from 145. So 145 minus 129.4. That deviation is already positive, 15.6. So I can just go ahead and have my deviation of 15.6. Our next deviation, 108 minus the mean of 129.4, gives me a deviation of negative 21.4. Make it absolute, so it is positive 21.4. Next data point, 160 minus the mean of 129.4 gives me a deviation of 30.6. It's already positive, so it is absolute. And then finally, our last data point was 122. We're going to take 122, subtract the mean of 129.4. We get a negative 7.4. To make it absolute, it becomes positive 7.4. And now we are ready for the mean absolute deviation. To do that, I'm going to take all of these deviations I just calculated, and I'm going to find the mean of those. So step one for mean is to sum my values. So 17.4 plus 15.6 plus 21.4 plus 30.6 plus 7.4. I get a sum of 92.4 when I add all my deviations together, and then my final step is to divide by how many elements were in the set. There were 5 deviations, so I'm dividing that by 5, and I get a mean absolute deviation of 18.48. All right, let's try another example. This time our data set is 1, 3, 7, 11, and 13. Grab a sheet of paper and build a table with me. My first column, I'm going to list all my data points. 1, 3, 7, 11, and 13. Now let's calculate our mean. So to calculate mean, we're going to sum the digits. 1 plus 3 plus 7 plus 11 plus 13. I get 35. I'm going to divide that by the 5 elements in the set, and I get a mean of 7. Now I need my deviations. To calculate my deviations, we're going to subtract each data point from the mean. Starting with 1, 1 minus 7 gives us a negative 6. Don't forget those deviations need to be absolute, so the absolute value of negative 6 is positive 6. My next value is 3, so on my calculator, 3 minus 7, I get negative 4. To make it absolute, it becomes positive 4. Our next data point is a 7, and I'm going to subtract the mean of 7. 7 minus 7 gives me a deviation of 0. My next data point is 11. 11 minus 7 is 4. And finally, 13 minus 7 gives me a deviation of 6. We are ready for mean absolute deviation now. We're going to find the mean of those deviations. So on my calculator, first finding the sum, 6 plus 4 plus 0 plus 4 plus 6. I get a total of 20, and I'm going to divide that by 5 because there were 5 deviations in the set. Gives me a mean absolute deviation of 4. Okay, boys and girls, I have one data set on the screen for you. I'd like you to try to calculate the mean absolute deviation of this set on your own. So copy down the numbers, pause the video, and work this out. Once you've calculated the mean absolute deviation of the set, begin playing the video to check your work to see how you did. Okay, boys and girls, hopefully you gave yourself enough time to complete. Let's go over this. I'm going to start by building a table just to keep everything nice and organized. I got 1, 2, 2, 2, 4, 4, 4, and a 5, squeezing in down there at the bottom. Looking for my mean first. Summing my data points, 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5. 24, 1, 2, 3, 4, 5, 6, 7, 8 divided by 8 gives me a mean of 3. Now time for our deviations. 1 minus 3 is negative 2, so the absolute deviation is positive 2. 2 minus 3 is negative 1, so I get a positive 1 for the absolute deviation. Same thing with the other 2's, they're both going to be 1. And then 4 minus 3 is a positive 1. 1, 1, and 1 for those 4's. And then 5 minus 3 is 2. Finally, our mean absolute deviation, we're going to sum those digits. 2 plus, what do we got? 1, 2, 3, 4, 5, 6 ones. 6 plus 2 gives me a total sum of 10, divided by 1, 2, 3, 4, 5, 6, 7, 8. Numbers in the set. My mean absolute deviation, 1.25. Boys and girls, make sure you complete the independent practice assignment associated with mean absolute deviation. Take a picture of your work and upload that file for submission. I'll see you guys next time.